Hi friends, welcome to the Unit 3 Day 4 notes. This we're going to talk about the graph of the polynomial function. For this particular example, what we're talking about is all the guidelines that give us different types of, or different parts of the polynomial function. And then this gives us good steps to kind of follow to get the rough estimate of the graph. I'm saying rough estimate. There's a lot of things that go on to a graph, and depending on the complexity of the graph itself, you may not be able to get all of this information.
Interruption. Tammy Slavens, please call 4009. Tammy Slavens, please call 4009.
Miss Rushton is providing that wonderful break for us. So here we have step 1, determining the end behavior. We talked about that in this particular section. Remember, the end behavior is determined off of the degree of the polynomial and then the sign of the leading coefficient. So that gives us the end behavior. So that's for part 1. For part 2, finding the y-intercept, it's always going to be 0, comma, and then whatever value it says. Here it says a sub 0. Essentially what you're doing is you're taking all of the constant terms from either the factored form of the polynomial, or it's just taking the last term if it's written in standard form. And it's always going to be 0, comma, whatever that is. So if you have to, you'll have to multiply them out to find whatever that value is, depending on the situation. And then also, you can plot this on the graph if you can figure out the scale. So this here starts to tell us the scale of the graph. So most often, you will want to do a 1-to-1 scale on your graph. What does that mean? That means for every one value you go up on your x-axis, you go up on your y-axis as well. Sometimes, though, it's impossible to do that because the x values either increase very quickly or increase very slowly compared to the changes on the graph. We'll talk about this here shortly. 3, find the zeros using any combination of the rational zeros theorem. That's from previous section. Factoring remainder theorems, also from the previous section, and the quadratic formula, which we learned back in, or we reviewed back in chapter 1. So the zeros, remember your zeros are your x-intercepts. So this also now kind of finalizes whatever the scale is going to be. At this point, you can now figure out exactly what your scale is because you'll have the y-intercept and then your x-intercepts. The important thing to note is that you do want to make sure that you have your y-intercept and your x-intercepts all on your graph or grid, if possible. And then this is where it talks about using the y-intercept and behavior multiplicity, and the mid-interval points is needed to sketch a smooth continuous curve. Again, the goal is to sketch it as best as possible. So here we're using, basically we're combining all of this. And then you might have to get more. So it says mid-interval points. Mid-interval points means that you're using points that aren't given either from your x-intercepts or your y-intercept. Maybe you need to plug in another value that's in between those two so you can see and in fact make sure that it does go down or go up, depending on the shape of the graph. Notice that we're also talking about the multiplicity of each zero. You can tell if the graph is going to bounce or cross using that information. Down here it talks about other tools to be used. These are other things that we've talked about that you can help figure out the shape of the graph or going through and actually graphing it. In the next example, we'll go over graphing, one of the examples here, and then another example as well. Join me in the next video as we talk about example 4, graphing a polynomial function. Have a great day.